I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This video is for direct variation. It's part of Unit 3, Lesson 4. So what is direct variation? Direct variation is a special type of linear function that can be written in the form y equals kx. The y-intercept is 0. The constant of variation is k. And k is equal to y over x. So I put the ratio of y over x. K equals y over x. So when your y-intercept is 0, then your slope is going to be what equals k, and your y-intercept again is 0. So it says identify if the following are examples of direct variation. So is this y equals kx? Yep, it looks like y equals kx to me. And also you need to note that k cannot equal 0. If k is 0, then it's just y equals 0. That's not direct variation. All right, so that's y equals kx. In this example, k equals 5. In example B, well, the y is not by itself, so let's get the y by itself. So minus 3x on both sides, negative 8y equals negative 3x, because 0 minus 3x is negative 3x. Divide by negative 8. So y equals a negative divided by a negative is a positive, so that would be positive 3/8 x. Well, that looks like y equals kx to me, and k is 3/8. So notice this is, example B is in standard form. If the equation is in standard form and it's equal to 0, then that is going to be direct variation. If you look at example C, it's standard form, but it's equal to 10. Therefore, this is not direct variation. So that's how you can tell direct variation from an equation. These examples are tables. So remember, the y-intercept needs to be 0. And also, we should have a constant ratio of y over x. So y over x is 0 over negative 3, and it's 3 over 1. Does 0 over negative 3 equal 3 over 1? No, it does not. So this is not direct variation. The ratios have to be the same. So this ratio is negative 10 over 2.5. Then it's negative 20 over 5. Are those the same? Well, if I multiply the numerator and the denominator by 2, then I get negative 20 over 5. So that appears to be the same. What about negative 30 over 7.5? So think about the first one, negative 10 over 2.5. If I multiply both of those by 3, 10 times 3 is 30. 2.5 times 3 is 7.5. So this is direct variation because the ratio of y over x is the same every time. Remember, these are all linear. We're not determining if this is linear or not. We're determining specifically if it is an example of direct variation. Over here we have 5 over negative 2, 3 over 1. Okay? 3 over 1 is 3, and 5 divided by negative 2 is not 3, so this is not direct variation. So to determine if it's direct variation from a table, you must find the ratio of y over x for every point that they give you, and if they're not the same, then it's not direct variation. Here's an example. The value of y varies directly with x. So that means we're going to have y equals kx and y equals 6 when x equals 12. They want us to find y when x equals 27. So what we need to do is we need to find k. And so in order to do that, we're going to substitute a 6 for the y and a 12 for the x. So 6 equals, I don't know k, I'm solving for k, times 12, because I replaced my x with 12. Now I'm going to solve for k, which means I'm going to divide by 12 on both sides. So now k equals 6 over 12 is 1/2. So my constant of variation is 1/2. So now I'm going to use that in my equation. So y equals 1/2 x is my equation. So I'm trying to find y when x equals 27. So I'm going to plug in a 27 for x. Half of 27 is 13.5. So when x equals 27, y equals 13.5. So if they give you a problem like this and they tell you that something varies directly with something else, then you know you have direct variation and you can solve for the constant of variation, which is k, in order to then use that to find another value. Okay, so direct variation, again, the y-intercept is 0, so direct variation always goes through the origin. Remember that when you're looking at a graph, if it does not go through the origin, which is the point 0, 0, then it cannot be direct variation. It can be negative, but it has to go through the point 0, 0. That's how you determine from a graph if it is direct variation.
I've been waiting way too long.